Now, everything that we did so far will only work against HTTP pages. The reason why it works against HTTP because, as we've seen, the data in HTTP is sent as plain text, so it's text that humans like us can read and understand. That's why when we're the man in the middle, we're able to read this text, and if we wanted, we're able to modify this text as we wish. Now, this is obviously a problem, and this problem was fixed in HTTPS. So, as you know, most websites these days use HTTPS, and all good websites, famous websites, use HTTPS. The reason why, like I said, because it's a more secure version of HTTP, and basically the way it works is it adds an extra layer over HTTP, which is where the S comes from. So it's a secure HTTP protocol, and this extra layer will encrypt the plain text data that HTTP sends. So if a person manages to become the man in the middle, they will be able to read this data, but the data will be gibberish. It will not be readable to the person intercepting the connection. Now, HTTPS relies on TLS or SSL to encrypt the data, and this is very difficult to break. Therefore, in order to bypass this, the easiest method is to downgrade HTTPS connections to HTTP. So, since we're the man in the middle, we can check if the target is requesting a HTTPS website, and instead of giving him the HTTPS version of that website, we will give him the HTTP version. This way, the data will be sent in plain text and we'll be able to read it exactly as I showed you in the previous lecture. To do this, we'll have to manually configure and use a tool called SSL Strip, and I show how to do this in my more advanced courses. But luckily, Man in the Middle F automatically configures and starts this tool for us. So, before I even run Man in the Middle F, I'm just going to go to the target Windows machine, and we're going to go to a target website, and let's try to go to linkedin.com. And as you can see, by default, the website loads over HTTPS. So you can see the HTTPS in here. This means everything that is sent to and from this website will be encrypted. Now, what we're going to do is we're going to go back here, and I'm going to run Man in the Middle F using the exact same command that I ran before. Because like I said, it automatically starts SSL Strip. So if I hit enter here, you'll see that it's telling us SSL Strip is online. So basically, Man in the Middle F right now is poisoning the network and putting me in the middle of the traffic, allowing me to intercept the data sent to and from the target. And at the same time, it ran this tool, which will detect if someone is trying to access a HTTPS website and downgrade that to a normal HTTP connection. So let's see how this is going to work. I'm going to go back to my target, and before I actually go to LinkedIn, I'm going to close the tab, and I'm going to delete my browsing data because I just loaded the website. So if I load it again now, it'll load over HTTPS. So we're going to delete the browsing data and go to LinkedIn again. And as you can see, the website is not loading over HTTPS. So you can see in here, it's not saying HTTPS. This means the website is loading over normal HTTP. And if I log in, so I'm going to put a username, let's just say zaid@gmail.com, and put a password. Then I'm just going to put 123456789. Now keep in mind, Firefox shows this notification anyway, even without the attack, as long as there is an input for a password in a HTTP page, it will show this notification. So this has nothing to do with the attack that we're running right now. So I'm going to sign in, and I'm going to go back to my attacker machine. And if we scroll up, you'll see we have the username here, which is zaid@gmail.com, and the password as 123456789. And this was posted to linkedin.com. So again, as you can see, this is identical to what happened before, and the main reason is because we downgraded the HTTPS connection to a plain HTTP connection. So when SSL strip is working, all the HTTPS connections will be downgraded to HTTP. Now, since the connections are going to be downgraded to HTTP, that means the data is going to be sent in plain text, which means that we'll be able to read all the data that's being sent, just like we usually do with HTTP. Now, there is one exception, which is websites that use HSTS. Now, HSTS is used by Facebook, PayPal, and Gmail, for example. And basically, the way this works is the browser at the victim, at the target, comes up with a hard-coded list of websites that it should only load as HTTPS. So even if we try everything that we can and try to downgrade this connection to a HTTP, the browser will just refuse to load this page because it knows that this page has to load over HTTPS. Now, so far there isn't a practical way of bypassing HSTS. There was, but that got fixed. But I will update you as soon as there is a new way to bypass it.